Yes. Let's let's consider then this step and again and write the all coefficients in and this form. It's okay. So we obtain under this one. So look at this one and this term, this one and this one and this one, it contains a0. So and the a0 is a common factor here, and write a0 times 1 and this one. Yes, and also this one. Yes, this one. It's okay. This one, and also other parts contains as a one, and so use a different color. Maybe appropriate will be better. And as a one, and this one, this one, this one contains, and all coefficients here contains and is a 1, and so write x, and this one, and so this one. It's okay, so on. But be careful, and here, and it should be dot, dot, dot. Otherwise, this one is the not finite sum. It's okay, and that should be. And so, what is the first one? The coefficient of a0. Look at the coefficient of a0 and this part, and write the sigma notation. Use n is 0 to infinity, and look at this one, the general term right here. It's okay, from n is 0 to infinity, because right, the n is 0 and s of 1 0, x to the 0, 2 times 0 0 factorial, and so we obtain 1. It's okay. And the next one, so look at the next part, and this part, this one. So, and this one is, and the general, and this one right here, from n is 0 to infinity, because n is 0 gives the coefficient of n is 0, x coefficient is 1. It's okay. So, and we obtain under this line, it's okay, using the sigma notation, and so we obtain this one. A sub 0 is a constant, so this one is say that, and the y sub 1 is noted by y sub 2, and so a sub 0 and a sub 1 arbitrary constant. So we obtain, and here y, a sub 0, y sub 1, a sub 1, y sub 2. And so we know from calculus and one and the summation cosine and sine. And so we obtain y is a0 cosine x and sine x. Yes, we obtained this result. It's okay. So, but be careful, and here critical point, and also, and this one is y sub 1, this one is y sub 2, this part. It's okay. So, and fundamental should be fundamental solutions, because this one is the general solution, fundamental solution. And how to check that this one is fundamental? You have to compute the Wronskian and which point, and is 0, because and the ordinary point is 0 here, y sub 1 0. It's okay. So, and this one is, yes, y sub 1 and cosine x, sine x, and right here. Or, and if maybe you know, you don't know, and this one, look at this line. It's okay, this line. Omit this part. We obtain y sub 1 this one, y sub 2 this one. It's okay. Or this one, y sub 1. So, and compute and the derivative, and but right, y sub 1 0. It's okay, compute. And this one derivative we get, and this one is 0 plus. This one is minus and 2x and 2 factorial this one, and also, and not this one, sorry. I think and use this one. It will be better. It's okay. It is easy to see that, and this one and this one, and but okay, maybe we don't know this one. omit this one. Maybe we don't know. Y sub 1, this one. Y sub 2, this one. But Wronski indeterminate is equal and is 0. It's okay. Is equal y sub 1, 0. Y sub 2, 0. Y sub 1 prime 0. Y sub 2 prime 0. It's okay. Should be non-zero. Y sub 1, 0. Y sub 1, 0. This one. Y sub 1. And substitute 0, 0, 0. We obtain and the 0 here. We obtain 1. This one is 1. It's okay. Y sub 2, 0. And this one is y sub 2 and 0, 0, 0, 0, 0. So we obtain 0. And compute the derivative and the second line and derivative and take this one and compute the derivative and this one and the derivative and 0. This one gives minus 2x over 2 and plus 4x cubed over 4 and contains x all of them. And substitute to 0 and this one is 0, 0, 0. So we obtain 0. And so the next one, y sub 2 prime, this one. Y sub 2, this one, prime, and so differentiate with respect to x and 1 minus 3x squared over 3 and so on. And the substitute x is 0, 0, 0, 0. So we obtain only 1. This one. So we obtain 1, not 0. So means fundamental. It's okay. Fundamental solutions. And also, look at our question here, and also if our question and here question, find the series solution of the differential equation and where and x0 is an ordinary point. Yes, but and the question if and find the solution of the these differential equation and how to find and write this one is a constant and constant coefficient linear and second order differential equation. So we know how to solve. Write the characteristic equation. Characteristic equation gives the complex number and the lambda here, and we obtain r is plus and minus r. R is plus and minus I, and complex number. So lambda is 0 and mu is 1, and so e to the lambda t cosine mu t plus sine mu t is okay. This one, but here be careful, sorry, and here c1 plus c2 and e to the lambda t, lambda is 0, so this one gives 1, so we obtain, and this one is 1 and 1, so we obtain this one. It's okay, solution. So we obtain and the same solution. It's okay here. Cosine C1 cosine x and C2 sine x. It's okay. Yes. Any question about the solution? And another type. It's okay. Another type. And maybe our point not ordinary point. It's okay, not ordinary point. Not ordinary point maybe, and the coefficients not 0 at this point, maybe 0. It's okay. And this and the point is called a singular point. Singular point. So and let's have a break 10 minutes and then we consider if and our point not ordinary point, if a singular point, what can you say about then the solution? And if singular points, we have two and the type of the singular points and the regular singular point or irregular. It's okay, we consider this one. Let's have a break and 10 minutes and then we will give the these cases. Okay.